editor here. Editor here. Special much superior compared to the cognitive design program. If it is within this one religion, then it will say
Okay, so good morning. So in this evening, we will be discussing about complex numbers. So we will be going through the all about complex numbers in this topic. So if you have any questions or if you have any qualifications during the discussion, so you can always send it to our group chat. Okay, so first we will be going about the definition of a complex numbers. So first we will go to the term as an imaginary number. So we have here the square root of -1. So the square root of -1, it is equal to I. Okay, I believe there is no output here. Okay. So the square root of -1 is I. Okay. Then if we have the square root of -1 is equals to I, this is now called as imaginary number. Okay. So for example, if we are going to square our I, so we will have -1 squared. So our I squared now is equal to -1. Now if we are going to raise our I to the power of 3, so that will be equal to square root of -1 raised to the power of 3. And if you are going to using the property of exponent, so we could write this one as square root of -1 squared, square root of -1 is equal to I raised to the power of 3. So we have square root of -1, this is -1 times square root of -1, which is equal to I cube. So our I cube is equal to negative square root of -1. Then lastly, we have I raised to the power of 4. Okay, so this is now equal to square root of -1 raised to the power of 4. Consequently, we could use the property of exponent to decompose this one into square root of -1 squared times square root of -1 squared. So we will have -1 times -1. So our I to the fourth is equal to -1 times -1 is equal to 1. So using this, we could say that we'll have our generalization here. So I squared is equal to -1. I raised to the power of 3 is equal to negative square root of -1, and I raised to the power of 4 is equal to 1. Okay, so we will be using this property of imaginary numbers in an example. Okay, so for example, we have I raised to the power of 1999 plus I raised to the power of 2004. So we'll be going to get the sum of this one. Okay, so the very first thing for us to do is first to multiply our exponent, this one and this one, with 4. Okay, so we have, let's put this here. We will use this black one. So 1999 divide 4. Okay, so we will just be using our calculator. Let's first get our calculator in the screen. Okay. Okay, so we have here our calculator. Okay, so we have 1999 divide 4. Okay, so this will be equal to 499.75. Okay, so we have 499.75. Okay, so this is 499.75. Then we will also, the 0.75, we will just multiply that one with 4. So we have 499 plus 0.75 times 4. So we could have 499, so 475 times 4. Okay, maybe we could adjust our calculator. Okay. So we have here 409, no, 0.75. So 0.75 times 4. So this is equal to 3. So we have 499 plus 3. Okay. Now, so we could have our exponent as I. We will use the same color for this one. So I is equal to 499 plus 3. Then for the next term, so we will also divide that exponent to 4. Okay, so we call upon again our calculator. So we have 2004 divide 4. This is equal to 501. So no need for us to multiply the exponent by 4 because it is the decimal by 4 because it has no decimal places. Okay, so we have plus I raised to the power of 501. Okay, then we could have this one using the property of exponent. So we have 149 times I raised to the power of 3 plus 5, plus I raised to the power of 501 is equal to, so is equal to certain number. Now because this is a 4, so this is This is now divisible by 4. So this will be equal now to 1. And also this is equal to 1. Because I raised to the power of 4 is equal to 1. So we could say this one as, let's just clear this one out. Okay. So we could have this one as I 499 times 4. I is the power of 3 plus 5 plus I 501 raised to the power of 4. Okay, then this one, maybe we should have this 409 outside the parentheses, just so that to make it clear that I raised to the power of 4 is equal to 1. So this is 499, this is 501, no, this is 4, this is 501. So this is equal to 1, this is also equal to 1. Then our I is the power of 3. So that is from this one, this is equal to negative 1. So we have 1 times square root of negative square root of negative 1 plus 1 is equal to the answer. So could say that that I is the power of 1999 plus I raised to the power of 2004 is equal to negative square root of negative 1 plus 1. And this is now our answer. Okay, so if you have any questions, so don't hesitate to ask in our group chat. Okay, so we will have another example. So we have this one. So this will be number 2. So maybe we could have I raised to the power of 64 minus I raised to the power of 84. Okay. So again, we will just divide our exponent with 4. Okay, so let's just have our calculator here. Okay, so we have 64 divide 4. This is equal to 16. Okay, and 84 divide 4. So we have 84 divide 4. So this is equal to 21. So 21. So we could write our equation, our given as I raised to the power of 4 times 64 minus I raised to the power of 4 raised to the power of 21. So no, this is a 64 but 16. Okay, so let's just erase this one. So this is 16 equal to, so this is I raised to the power of 4, that is equal to 1. I raised to the power of 4, that is equal to 1. So we have 1 raised to the power of 16 minus 1 raised to the power of 21. So we have 1 minus 1, and this is now equal to 0. And this is our answer for this problem. Okay, so far there's no question in the chat. So we'll proceed with the next part of our topic, in which we are going now to get to know the complex number. Okay. Okay, so the complex number is given by the notation as z. So z is equal to x. If you are going to have this as a coordinate, so that is x and x, y. So our x, let's just move up our board here. Okay, so our x, it is called the real part, and our y is called the imaginary part. Okay, so if we are going to denote our complex number into one of its form, which is the rectangular form. So the rectangular form of our complex number, okay, so the rectangular form is that z is equal to x plus jy. So j is another notation for I. So I and j is equal. So this is equal to square root of -1. So usually if we put our j before our variable of our number, so we will use j, but if it is after our number, so we will use I. So we could write also this one as x plus yi, but usually we will use j, especially if we are going to have an analysis. So an example of an complex number in a rectangular form, for example, if our real part, our x, is equal to 7 and our y is equal to 8, so we could write our complex number as 7 plus j 8. Okay, so if another imaginary number, example, we have our x is 8 and our y is -9, so we could have our complex number as z is equal to 8 minus j 9. Okay. Okay, next we will go now to the addition, no? Addition and multiplication of complex numbers. Okay, so for example, we have our z1. We use the black pen. Okay, so z1 is equal to x sub 1 plus j y sub 1, and our z2 is equal to x sub 2 plus j y sub 2. Okay, what will be the sum if we will have z1 plus z2? Okay, so we will just write that one, x sub 1 plus j y sub 1 plus x sub 2 plus j y sub 2. Then we will just add the real part of the first given complex number to the real part of the next given complex number. So we could write that one as x sub 1 plus x sub 2 plus, then we factor out the j, y sub 1 plus y sub 2. So that is, this is for addition, no? Addition. If we are going now to go to multiplication, so we have z1 raised to the power of multiplied by z2, so we'll just use the asterisk here. Then we will have x sub 1 plus j y sub 1 times x sub 2 plus j y sub 2. So in multiplication of complex number, we will treat these two numbers as a binomials. So if you are going to multiply binomials, so we could use different methods, whichever is your fancy. Okay. So we could use the FOIL method. So we could have this one as x sub 1 times x sub 2. So this one. Then we will just distribute this next one here plus j x sub 1 y sub 2. And we could have this one also. It will be j y sub 1 x sub 2 plus j squared y sub 1 times y sub 2. Then we could simplify this one. We will have x sub 1 x sub 2 plus j x sub 1 y sub 1 plus x sub 2 y sub 1 plus this is j squared or I squared, that is negative 1 y sub 1 y sub 2. Then simplifying further, we could have x sub 1 x sub 2 minus y sub 1 y sub 2 plus j x sub 1 y sub 2 plus x sub 2 y sub 1. That is the product if we will multiply two complex numbers. So if you have any questions again, so you could just ask the questions through our group chat. Okay, maybe we will have an example for this part of the topic. So for example, we have our z sub 1 is equal to 9 plus j 8, and our z sub 2 is equal to 7 plus j 3, or maybe we could have this one as negative so that it could be more challenging for us. Okay. So we will try to find z1 plus z2 and z1 times z2. Okay, for z1 plus z2, we will write here our solution. Okay, solution. For z1 plus z2, okay, we will have this one as x sub 1 x sub 2 plus j y sub 1 y sub 2. So our x sub 1 in our given, so this is the x's, or that is the real part, and this is the imaginary part. So we have 9 times 7 plus j. So our y sub 1 is 8. Then our y sub 2, so this is minus, so that will be negative 3. So we will have, so 9 times 7, that will be 63. 8 times negative 3, that will be negative 24j. So this is our answer. Okay, I believe this is not times but plus. Okay, so we make a grave mistake on our solution, so let's just erase this one, because I was wondering why I was using multiply, then our operation is plus. Okay, so this will be plus, so sorry for that. So x sub 2, y sub 1, y sub 2, so that will be addition. So let's just erase this one and this one here. So we will have 9 plus 7, okay, it will be 8. Okay, so I guess we have to continue. So the current just returned, so due to the curtailment by Saneco. So I believe some of you are not able to go back to the live stream because maybe your place have been part of the curtailment. But don't worry, I will be also sending a copy of this to our Google Classroom. Okay, so we continue now with the solutions. So we have 9 plus 7. So 9 plus 7, that is equal to 16. So this one, so this is equal to 16. And this is equal to 8 minus 3. So this is equal to 5. This is equal to 5, and that is now our answer. Then we will go to the next one, that will be z1 times z2. So we have, using our formula, it will be x sub 1 x sub 2 minus y sub 1 y sub 2. It will be j plus x sub 1 y sub 2 minus x sub 2 y sub 1. Let's just check here our formula. Okay, so that is correct for this example. Okay, so we have our x sub 1, okay, that will be 9 times 7 minus our y sub 1, that is 8 times negative 3 plus j. So our x sub 1, this is 9 times y sub 2, this will be negative 3, minus our x sub 2 is 7 times, is it minus, okay, so plus, so this is plus. Okay, so this is plus for per formula. Then our y sub 1 is 8. Okay, so we have 9 times 7, that will be 63, negative 24, so that will be plus 24, plus j, negative 27, that will be 7 times 8, that will be 56. Okay, so we have 63 plus 24, this will be 87, plus j, so we have negative 27 plus 56. Okay, so negative 27 plus 56, and that will be equal to 29. So we have plus j 29. Okay, so we just write here our answer so that it will be much clearer. So we have 87 plus j of 29. This is now our answer. So if you are using a 911 or 570 ES calculator, so it will be much easier for you to check your answer. Okay, so we will use here the calculator technique in solving complex number, so addition and multiplication of complex number. So this is just for checking. Of course, during our quiz I will be requiring the solution for that one. Okay, so let's just adjust our calculator to make it much larger. Okay, so let's have here the given. So the given is first we will set our calculator. Okay, so we have mode, then we'll go to 2, that will be the complex, then we'll just copy our given. So it's just move our screen here. So we have our z1, so that will be 9 plus 8. Of course, in our calculator there will be no j because the calculator uses I, so we have I, then plus, that will be 7 minus 3i, and our answer will be equal to 16 plus, okay, this is plus, so we made a mistake on our sign here because 8 minus 3, that is not negative 5 but plus 5, so we just correct that one. So plus 5, then for the multiplication part, okay, so we have times, okay, multiply, so that is 87 plus 29i, or 87 plus j of 29. So this is correct. So our first for the sum, so we just made a mistake on our sign. Okay, so that is how we are going to multiply and add complex numbers. So if you have again any questions, so you just message on the chat box or in the group chat. Okay, so I am looking now at the group chat, so there are no questions so far. Okay, there are no questions, or some of you are just thinking of something else. So I hope you understand the discussion for tonight, because next meeting we will have our first quiz. Okay, of course after this one I will be giving the assignment for this week, which will be passed on Friday. Okay, then we will go now to the last part of our topic, which is the division of complex numbers. So division and subtraction of complex numbers. Okay, so for the division of complex numbers and subtraction, so we'll be using the so-called conjugates, especially on the division part of complex numbers. Okay, so for example, we have again here our z1, that will be x sub 1 plus j y sub 1, and z2 is x sub 2 plus j y sub 2. Then our we will have z minus z sub 1 minus z sub 2. Of course, subtraction is just the opposite of addition, so we could have this one as x sub 1 minus x sub 2 plus j y sub 1 minus y sub 2. So this is very easy. Okay, so we just change the formula for our addition into minus, okay, for the symbol for subtraction. So in summary, if you're going to add or subtract a complex number, two complex number or more complex number, you just get the sum or the difference of all the imaginary part and the sum and the difference of all the real part, and you will have your answer. While on division, okay, so division is far more complicated because, for example, you have this one z1 over z2, that will be x sub 1 plus j y sub 1 over x sub 2 plus j y sub 2. Okay, so in this part you are now going to get the conjugate of the divisor, or if in this case in our illustration, the conjugate of our denominator. So the conjugate of a complex number, so conjugate of a complex number so if you have our complex number x sub 1 plus jy sub 1, so that is just the same real part and imaginary part, except the sign is opposite. So the conjugate of this one is x sub 1 minus jy sub 1. Consequently, if you have x sub 1 minus jy sub 1, the conjugate of that one, maybe we should not use the term equals, no, but conjugate. Okay, so we will have this one as conjugate. So we will write this one as conjugate. Okay, conjugate. So conjugate, this is conjugate, no? Okay, so this is equal to x sub 1 plus jy sub 1. Okay. So for this one, so we will in dividing a complex number, we will multiply on the numerator and denominator of our given the dividend and the divisor. We will multiply the conjugate of the divisor in the numerator and denominator. So we could write this one as multiplied by x sub 2 minus, so because this is the denominator, so the conjugate of that one is x sub 2 minus y sub 2 over x sub 2 minus jy sub 2. Okay, so now we will use the multiplication of two fractions. So we could have this one as x sub 1 jy sub 1 times x sub 2 minus jy sub 2 over x sub 2 plus jy sub 2 times x sub 2 minus jy sub 2. So if we will use what we learned on the previous part of the topic, so this is just multiplication of two complex numbers, and this is also the same. So we could have this one as x sub 1 times x sub 2. Then we have minus, or we could have plus minus j. So this is distribute our x sub 1, so that is negative j x sub 1 y sub 2 plus j y sub 2 x sub 2. Then we have negative j squared, that is y sub 1 y sub 2, okay, over, so this will be x sub 2 times x sub 2. Then we have plus, minus, so we could have plus negative j x sub 2 y sub 2 plus this part here, so that will be j x sub 2 y sub 2 minus j squared y sub 1 y sub 2. So this one will be equal to, so the upper part first we have x sub 1 x sub 2, then this is negative 1, so times negative here, so it will be plus y sub 1 y sub 2. We have minus j, so we factor out the, or we just have this as positive j, that will be y, x sub 2 y sub 1 minus x sub 1 y sub 2 over, this will be equal to x squared, x sub 2 squared plus, this will be 0. Okay, so they are the same term, opposite in symbol, or opposite in sign, so this is equal to 0. This is negative 1 times 1, so that will be plus, this is y sub 2, so that will be y sub 2 squared. So this is now basically the formula for the division of two complex numbers. Okay, so you just use this formula in getting the quotient if you divide two complex number. Okay, so I believe we are running out of time, so we have 6 minutes before 7, so I believe we will just end our discussion here. Of course, I will be sending the assignment for this one, for the whole topic, and also a supplemental or additional video showing the example on how to solve the difference, the quotient of two complex numbers, so that is the subtraction and the division of two complex numbers. And next week we will have our first quiz for this subject. So thank you for watching this video, and as always, keep on studying.
Within this one, if